So, just to get away a bit from all those third-person shooter stuff we're doing, we're going to see something entirely new. And this, of course, has to do with, making a game like Tabletop Simulator or something like that. And of course, Tabletop Simulator has a lot more features. We're not going to see all of it. We're just going to make a base. So if you want to keep adding features, you can do so. So, for example, we're going to see some examples and how we can work with pawns. We're also going to learn inheritance. We have done some in the past. We're going to delve way deeper this time, and we will see how we can move pawns. Okay, and dice, and the dice will actually have its own behaviors, and okay, like this. We can actually group select everybody, and I'm going to copy this. We can reset their orientation if we press F. And one other thing that we can also do is, let's call this token pawns, which if you take them, and you can see that they write a play on top of this. So for example, let's say this is an explosive token or whatever, if the bank doesn't give it away, but if you drop it and hit play, it will not only play a particle system, okay, an explosion, but you can see that it will also add force like an actual explosion. So if you were making a game, let's say a World War II game, right, and you want to simulate an explosion or something like that, then you can simply do it like this. And another thing you can do is, for example, if you want to simulate dust cloud or poison cloud or whatever, you can also do this. And these are not one-time shots. These two are basically, we can open them and close them, and this is just fire. Of course, since it's fire, then you can do something a little bit more creative in this case and get this, and you can also summon Satan or whatever. Okay, but I've had this closed because you can see there is a little bit of a bug over here, which is, for some reason, it creates the line renderer. It creates it from, places it somewhere that it shouldn't. You can see there's some transition anyway. Yeah, and we're also going to see how we can group select all of these. So this can also be worked as with a little few tweaks, or the lessons we are going to learn over here can also be used for an RTS game, or basically any game that has to do with multiple units and units that are different from each other. We're also going to see all of these basically start as one point, or they are basically the same thing, the same object, and with inheritance we're going to separate them, and every one of these will have its own behaviors. For example, the dice is going to have it's going to have its own behavior, when it will also give you a note on top of this in the UI, which at this point is wrong. It's wrong because it was intersecting with the collider. Okay, and you will see why this was wrong. Okay, it will also give you the basically the value it has, and we're going to basically create a little bit of a framework, a small framework or prototype or whatever, that will help you work with and make any dice you want, or at least have a way to create any dice you want. However, we're only going to see a 6-sided die because it's way too easy to create a 6-sided die. Like, oops, yeah, it went under the collider, so it went under the floor. So yeah, as I was saying, there's a secret to 6-sided dice, and if you want to learn it, then by all means keep watching. So the first thing we're going to see is to actually see our pawns. Okay, as I said, every one of these are pawns. However, they are both pawns, but they are different pawns. They have the same base, so that means we can use them as a user interface level. We can use them and use the same logic to move them around, rotate them, and stuff like that. And also, yeah, if I click something and hold the right click, we can also rotate our guys. But if I select a dice, then the rotation is a little bit more random. Okay, and this will work with any one of these. And also box selection. And box selection, the way it works, okay, normally when you click on somebody you can move him, but in box selection, when you do a box, you can move it around, and they basically move with on the mouse position with the offset. So if you want to have you can also copy one of these hitting S. Okay, so if you want to have a formation, you can simply move all of them together, and with F you can reset its orientations. Okay, so again, all of these are pawns, even the die, even the tokens, all of these are pawns. And let's see to the scripts, and we're actually going to see our class of pawns. Okay, you can see that it takes from model behavior. We can use a pawn ID, however I'm not using it for anything at this point. I wanted to make databases and a list so we can use also asset bundles and all that. However, we have done that so many times before that I felt a little bit that it was unnecessary to drag that much for the series. However, yeah, if there is too much demand, then I'm going to make more parts for this one, and we can also go and add multiplayer too. So yeah, there's a lot of stuff we can do. However, yeah, we're going to see I'm going to purely base it on how much demand there is for this. Okay, basically every pawn will have a rigid body and a collider. Okay, because we want to interact with them, and we also want to move them inside our scene. The integer value, basically if you want to have strings, I think, yeah, I placed it over here, but I should have probably placed it inside the dice. Anyway, we'll do that little change in a bit. Game object selector is the game object or the sphere object that you see on top of the selected pawn. Okay, let me unmaximize this since there's no need. And is active if the actual object is active, which will also be useful in multiplayer. However, we're not going to see multiplayer in this one, in this part at least. So public void init, of course, when we want to initialize. And what I'm going to do is, of course, get the collider, get my rigid body. I'm going to create a primitive, just a sphere at this point for the selector. Okay, it's the easiest way to do it. The primitives also always have a collider, so we're also going to destroy that collider. We're going to parent it under our transform. We're going to change the local scale, place it a little bit, up, reset the rotation if there is any, and then simply deactivate it. Then we have a list inside our player control script, which we can, which we are going to save all our pawns. Okay, this is the base class, so everything else, we're not going to use this class exactly as it is. We're going to take from this class, and we're going to use inheritance to basically override all of this. So you can see that these are empty functions. However, that means they are not actually empty, they are virtual. We're using virtual because on a child class we have the ability to override these functions. Okay, if we use abstract over here, then that means on all child classes you absolutely have to include these ones also. However, we're going to keep things more open-ended, so we're going to simply use virtual void. And for base, on start, on mouse down, we're just simply going to leave them empty. Save offset position, we're going to use them so on mouse down as group, so when we are moving them as a group, we're basically moving them on the mouse position with an offset. That offset, okay, is around transfer position minus the mouse position we are passing. The target position we want, mouse position plus offset position, okay. Yeah, we create the target position, we just add a little bit so they are on top of the ground, and then we reset. Yeah, oh, actually we're not resetting anything. This, yeah, this actually isn't really needed, so let's comment this out. So okay, on mouse down, it's a virtual void. In case I want something different in one of my pawns, I can simply override it. On highlight, it's the same, is active, selector, okay, active. On dehighlight, so I don't know what's the difference of on highlight and highlight, I don't know, desaturate, whatever, okay, is active, and then we close the selector. On highlight is when you're actually highlighting, so when you're basically drawing a box and inside that box there is the pawn, and on active is when you're actually moving your object. Okay, on active we simply set the rigid body to kinematic because we are moving based on the position of the mouse, and we call a function that it goes and registers the update or unregisters an update. Now, what this does is basically think of it like this. We have a lot of pawns. We're mostly focused on handling volume. Okay, if you have seen videos on Tabletop Simulator or any other game, they have a lot of pawns. If we have behaviors on each one of these pawns, so you have like 200 update calls, okay, each frame, there's no need to, basically, especially if you only have them activating or deactivating like pawns do. Okay, there's really no reason for that to happen, so we need to know which updates to run and when we do that, and that way we can have an update master which its sole purpose is to basically run the updates. And to do that, we need to register them. So what it basically adds this pawn into a list that is going to run its tick behavior. Since though this might be empty, but again, as I said, since this is a virtual void, that means we can simply overwrite it onto a child class, and then it will actually run the tick behavior from the child class. Okay. So when we want to update, we're using the update master, and when we want to stop updating, then we simply unregister. Reset orientation, again, every one of these you see empty means we're pretty much overwriting them. And this is just a simple coroutine that is going to reset the rotation. So we first make the rigid body kinematic. We find our position, we start from our position, we want it to go up, we change, we lerp it up basically, and I think we also had somewhere, anyway, when we call this we also fix the rotation also, so we will see this in a bit. Okay, rotate, reset orientation, register update, and register update. Let's close all this. And we were on highlight, on dehighlight, on active, On deactive, we make a rigid body again non-kinematic. We disable the selector and we also save the offset. Again, it's a virtual. We disable the saving offset. Okay, it's again a virtual void. Rotate pawn, again a virtual void. The trick part is the virtual void. We have our current Euler angles and we simply add 2 on our own y and we apply it back to our own Euler angles. When we want to follow the mouse, we find the target position. One way to do it is just take the mouse hit from the player control or use it like this. Okay, either way is fine. This and this will always be the same position. Transform position, okay, we'll see in a bit the player control. We have a target position and we also have a rotation. So this is our pawn base. So every time I want to call something like this, okay, every time I want to use one of my pawns, I'm basically going and calling one of these functions. However, because these are all virtual, that means we can simply overwrite them into our child classes. Okay, so you can guess that the dice will have a different behavior for deactivating than what the miniature will have. Okay, and we will see this also in a bit. Now, since we know what we have using on our pawn, we're pretty much ready to go and see what goes inside our player control. For player control, we need all this, pressing mouse, with basically which button we are pressing. The mouse hit again is where we are actually hitting our mouse. Enable edge move. So enable edge move is, I forgot to show this. If we hit play with this enable, when we move towards the edge, we are actually moving our camera. Okay, however, I'm going to disable it because it gets a little bit annoying trying to fix stuff over here and have your camera move. The edge threshold, how many pixels your mouse needs to be from an edge to start moving, and this is how much it's going to move, and this is the camera holder. The camera holder is just an empty game object with a camera inside. Well, you can make it also orthographic and it might look a little bit more stylized, I guess, or just leave it like that. The color canvas, just a reference to this canvas, and the box select is just a box, and you can see this. Okay, this is a default UI sprite and you just untick the fill center. And also the particles I'm going to use is basically the particles, okay, from this. And yeah, for the characters you can actually, they do not have any animations. I just pose them with their transforms from inside the rig. Okay, you can just rotate their bones and place them somewhere anyway, it doesn't matter. You can actually have an animator playing animations, but keep in mind that if you have a lot of animations playing at the same time, yeah, the animator is a memory killer. Okay, it requires a lot of memory to, yeah, so it's really performant, or yeah, it's going to require a lot of performance. However, I think you can get away with around 100, or I'm going to say 100, but it might be a little bit less than that. Okay, and for the dice, I'm going to drop you a link in the description with this dice. Okay, I made it. I could have been a little bit more generous with the bevel, but anyway. Let's go back to the player controller. We have a list of our pawns, which is basically going to hold all of our pawns, all of our active pawns and all our pawns. And if the currently selected pawns, okay, the current active pawns are from a group selection. On start, we're simply going to just disable the box select image, and we have our some functions we're going to use. So mouse control, when we're pressing down the left button and where we are leaving it. Okay, we're doing a raycast hit, and we're doing a raycast hit all actually in this case. And now you're going to say why you're using a raycast all instead of a single raycast, and I will not really know why, what to answer there. Yeah, I probably had something else in mind, but just to be safe, let's write again, I guess. Okay, hit if physics dot raycast array out hit. Let's go with 100. Yeah, let's go with 100. And I think that will actually do. Like this. And let's drop the check hit. Let's take this also. Let's remove this, and mouse hit will be if not spawn. Mouse hit will be hit. Hit dot point. Let's test this because I have actually no idea if this is going to work. Yeah, it works. Yeah, it doesn't work just fine because you can see that when I move over another object, you can see that it stacks because the update doesn't because it doesn't update the mouse hit. So all of this was unnecessary, so let's bring back everything we wanted. Probably if I have left a comment over here, this will work. This will have been faster. Anyway, okay, we're doing a raycast hit, raycast hit all basically, raycast all, and we check from each one of these if we have hit a pawn. We call this function to check if any one of these hits is a pawn, and if some of it or any of it is not a pawn, then we are going to simply select to update our mouse hit. Okay, so what's not a pawn? A pawn, everything that is not the ground. Okay, so this is a kind of a safe way to do this. The check hit is this. We pass the raycast hit, and we have a reference boolean is pawn. We start with a get component. I'm basically doing it this way so I do not have to call this 2 times. Okay, we have and if it's the pawn is not null, then we say is pawn true. If you are not pressing the mouse or it's not the first frame you are in here, okay, then you are simply going on active, and yeah, we activate our pawn basically. Okay, this is the behavior we've seen into our pawns class, which we can override. We add the pawn into our list, and then we say it's the first frame, so if we hit the same thing again, it's simply going to ignore all the rest of it. Let's close this, and it's not a pawn, we update the mouse hit position. If we have a group selection, if this is active, then the way to do it, we of course need to check if our active pawns count is 0, then we are not anymore in group selection, so just return. Otherwise, that means we have at least one pawn, and we can do a for each loop for each pawn. Okay, in active pawns, we call the active on mouse down as group, and we pass our mouse hit, and when we are pressing the mouse again, we pretty much say first frame, deactivate the pawns, and then it's not anymore a group selection, and then we return. We basically skip the frame, so the next frame is going to reset. Deactivate pawns, all it does is, if it's not the first frame you are deactivating, just in case for some reason you are running this 2 times, then it's going to do a for each loop for each active pawn you have, and it's going to run the behaviors that you need to do on deactivate. Okay, and reset the first frame and clear your active pawns list. If your active pawns count is not 0, so that means you at least have 1, and you haven't yet started dragging a box, okay, because if we have already started dragging a box, then what this will have done will be to, when you're dragging a box and when you are over your pawn, then it will get this guy and select him, and he will be you will basically break your box selection. And you're pressing a mouse, it's going to look, again we're doing a for each loop just in case we have more pawns than one. Okay, and we're going to be running their behaviors for on mouse down. In this case, of course, means we are following your mouse. On deactivate pawns, or basically where we are not anymore holding the mouse down, we are simply running again deactivate pawns. The opposite of this, of course, will be box selection. So box selection, we need this, of course, if we have starter box and from and to. If we are pressing the mouse and we haven't yet started creating our box, we're going to store our from position, which is going to be our input mouse position, and the to, which is again the input mouse position. Then what we're doing, we're finding the x and y, the size. We're going to start with size of 0. That is because I do not want to use inside the update loop a new vector 2. Okay, you are not using constructors inside the update because it requires a lot of it will allocate a lot of garbage which you do not need. And we're going to make the size x and y the absolute value of x and y, of course, because there's no negative values on the UI system, on your UI canvas. Okay, you cannot add -50, I think. Let's try this. Yeah, you cannot. And then we apply the size delta, and we have we anchor the position of the box select to our very start from position. The way this works and why this actually works is that because in my box select you can see that I have both my anchor, which is this, it's selected this, which is lower left, and you not only need to add the anchor, you also need to add the pivot point, which is this blue circle. Just add it over here. Okay, and this will work with the system we have. Let's lower this and let's place it back over here or something like that. Now, okay, we have our anchor position, we have our size. We need to check though the scale. Since we do not have negative size, we can although change the scale. So we start with scale of vector 1. The scale, of course, is a vector 3. Okay, you can see it over here. So what it's going to do is it's going to see if your x or y is lower than 0, and then either apply -1 or 1, and then apply it to our box select local scale. Box select image, we are basically enabling it, and we're going to find to make a bounce. So this is where we're actually making we're basically checking if there is any game objects inside or any pawns inside our box. We need a camera, screen position 2. Okay, we use screen point to viewpoint from screen position 1 and screen position 2. Min max, we basically need to find which is the minimum and which is the maximum. We need to assign something on the Z, otherwise this won't work. We create a new bounce and we set the new bounce with min max we have over here. And thank you person, I do not remember his name right now. Anyway, I looked it up in the forums. So if you do not know something, then googling it really works. trust me on that. Okay, so we make a bounce over here, and yeah, this actually, I like this approach because it was really the simplest one I could find, and this actually is really nice. So we have a bounce, and so after that it's really easy to find if inside the bounce is a point in a world object. So what we're going to do is, for each pawns we have, we're going to use world to viewport point. Okay, and if the bounce contains the spawn position or the pawn position or the screen point position anyway, okay, then we are running on the pawn highlight and we are adding it on the list. If it doesn't contains the bounce, then you are dehighlighting and then you are removing from the active pawns. Now this works like a charm. However, there's one issue with this. It uses on the list of all pawns. Okay, which is something you do not really want to do if you have a lot of pawns. Okay, because you're basically searching in all your game objects. So what I will have do a little bit different in this case is that instead of having only one list of active pawns, I will have made another list, for example only pawns that are visible in the camera. Okay, however, yeah, this will just be a little bit more, yeah, it will have been overcomplicated in this case. So yeah, I will have, on a second step, I will have just filter only the pawns that are visible from the camera. Okay, so the way to do that, you need to add a mesh renderer or a renderer anyway, it doesn't matter. We only need to make sure that that renderer is visible from the camera. And if I remember correctly, is let's say we have a renderer, let's call it R. This is going to give us an error. Is visible. Okay, is this render visible in any camera? And this will give you a yes or no. So I guess you could just yeah, let's not add this. So anyway, I will have added a renderer over here, add something over here that goes and finds a renderer. Now keep in mind that if the renderer is obscure, then it's going to be invisible. So anyway, enough of that, and filter a list based on if your objects are seen by a camera or not. Okay, so that's basically how you box select. The opposite of that is if you're not pressing a mouse and you have already the box started, okay, then you simply deactivate the box select image and you are saying that you have already selected, you have dragged the box and it's done, so it's a group selection. So this one is going to come and basically play its behavior, which is over this. And I guess you could do an active pawn or 0 or active pawns dot count equals 1. Okay, so everything under, or I guess you can simply do less than 2, I believe. This will probably work also. Okay, so that's how you box select, and that is the part you can also use on an RTS, obviously. Okay, and yeah, we are only using it for highlight and dehighlight and activating and moving them, but you could just have them inside the list, and when you are assigning a move order or something, then run it for everybody inside the list. Okay, so I hope you can see and draw the parallels over there. Border edges is what's responsible for moving our camera when the mouse is on the edges. So the simplest way I could think of to do this is, of course, if it's disabled, then do nothing. Otherwise, get the mouse position, start with the target position of your camera holder with 0, and if the mouse position on the X is lower than the edge threshold, okay, then your target position on the X will be minus the move value. Likewise, if it's higher than screen width minus the edge threshold, then that means we want to move right, so apply just positive value on the X. Same for the Y, but for the Z, and then apply it to your camera holder. Rotate pawn. If you're holding down the right key, simply call the behavior for each pawn you have active and rotate it. Keyboard inputs has to do with the keys you can press. So for example, if you're pressing F, do a recast. If you hit a pawn, run the behavior for reset orientation. If you want to copy a pawn, okay, same thing as this. Yeah, I guess you can reuse some of the code. And if you hit a pawn, then simply instantiate it on top of your current pawn. Or if you want to do something else, then do so by all means. Check hit again. I said what it does. We've seen this. Add centrifugal force on all pawns. You pass a sender, you pass a force and a radius, and this is what actually adds explosion force from your pawn tokens. So for each pawn, centrifugal means avoids from the center towards the outside. Okay. Yeah. Actually, centrifugal is Greek words, so center means center, of course. Fugal means go away, and I'm not actually kidding. Fugal, yeah, it means go away. So go away from the center, basically. So yeah, you're adding explosion force. Add explosion force is actually a function from the rigid body, so you do not have to calculate the fall of the force you are applying on a rigid body, so that's nice. You need to pass a radius and a center and of course a force. Okay, and it's also a singleton. So these are the main stuff we need to see for the player control. Let's see the update master. The update master. We have a list to tick and a list of pawns we want to stop ticking. On start we do not need anything. So on the update, if we have anything inside our to tick list, then we are simply running their updates. If we have something to unregister, then we check, of course, if we have this inside this list, and then we are removing him, and every frame we are clearing our unregistered to tick. And we have these two functions to register a pawn to update or not. Okay, and again this has to do with, it's a singleton, and again this has to do with managing volume, so we can handle a lot of pawns basically. So this is the main architecture, and I think since we are at 40 minutes, I think I'm just going to make this into two parts, since there's a lot of stuff to cover with the miniatures. So like, subscribe, and you can also get this project from Gumroad, of course, and in turn you're helping me keep making a lot more of this. Let me know what you think of, this was something entirely different like you have seen from in the channel, and it's a pretty fun project. I actually enjoy this a bit. I actually love board games, and I have created a few of them, not some official, but it's just fun to just create board games because it's way too fast to prototype, which is really nice. So yeah, of course the other way you can support me is on Patreon. where you can also get scripts. You can also watch videos much earlier than when they go live, and of course, yeah, all that. So I'll see you on the next part.